Today's objective is to describe the redundancy of routing between 2 points on the internet. So yesterday we had talked about routers and packets and the data in the packet being separate from the IP address that the packet is going to. And don't forget there's also the IP address that the packet is coming from. And now when most people think of routers, they probably think about a router in the home. You have a laptop or a smartphone here, so you can from your phone check out your fantasy football team. So you would open the app that sends a request to the router through the modem and out into the internet and says, bring me that fantasy football team information. And then it comes into here. Okay, but the router I'm talking about in the past 2 days would be these internet routers where from your laptop, okay, you've made the request. And it goes through, a router in the home sometimes or just a modem. Just depends, and goes out to the internet. So here we are out on the internet, and you've sent a request to a particular server where maybe your fantasy football data is located. So when you make that request, it can go in any of these lines through any of these routers. And then once it says, bring me the information about my team, then it can go through the router back to your laptop or smartphone. So you're sitting there looking at your information now. Along the way, these packets, right, these packets of information, they can get lost or they can hit a dead end or get stalled out. So you could be here sitting at your computer saying, where's packet number 27? Where's the information on Kareem Hunt? I need to see his yards in his rookie debut. And you're not getting it. So at that time, something called TCP will, send a request to the server and say, bring me that packet 27. Or the server sitting there saying, like, I never got confirmation that packet 27 was received. So let me go ahead and just send it again. And so there's the redundancy. It just keeps sending it until a confirmation comes back saying the packet was received. So, with that in mind, I'm thinking routers are everywhere, right? A challenge question for my gamers out there. Is routers the reason lag happens in your video games? If you're in an intense battle on Destiny or some other game and you're suffering from lag, what's the problem? Seeing data traffic in real life is very hard, if not impossible, since only engineers of large networks have access to router data on a large scale. And it's also more complicated to understand. But today we're going to be baby network engineers. So go ahead and go to this website, studio.code.org, and the rest of it there. So go there. You could partner up with somebody, or just go there. I'm sure you'll find people around the room already there. And I encourage you to use this simulator to go ahead and have a conversation. It could be about anything. We have the homecoming dance coming up. You could talk about the NFL, video games, whatever. Today's activity using this internet simulator will be a little different. Messages will now have a to and from address in a format similar to the IP address, but it's just going to be an 8-bit address instead of 32 bits. Remember, we're baby network engineers right now. This allows messages to be sent to a single intended recipient. So once you get on there, you're going to see many possible recipients. You can go ahead and just choose one to message, okay? Think, right, share, where is this to from information stored while traveling? What thing is reading this information and routing it to the correct place? So let me go ahead and demonstrate here by going to that link. You're looking at something that looks like this. Down here, go to router, and you can send a message. When I first started this, I sent a message to absolutely no one. It said 200 from 1.10. I just said hello self. This is what it looks like in binary. See the binary connected to the ASCII, okay? So here I am, R. Houghton, sending something to nothing, okay? Then I went up and I typed in an address, 1.14. So here is Lopaki is Samoan for Robert. So I sent a message to Lopaki and I just said, how are you? And that's what the binary looks like in the message. Now, this message only went to 1.14, not Tiberius, my son's name, by the way. He is getting nothing. So that's the difference between direct communication and just broadcasting something out there to anyone. So I want you to think about that as you may be talking about the dance. Maybe you have some personal information you're sending to someone. How do you know for sure that someone, that address you're sending the information to, is the person you think you're talking to? So this internet simulator also simulates the routing of messages across a network, with messages possibly being routed across multiple routers in unpredictable sequences before finally being delivered. This is done to simulate the way traffic traveling across the internet is constantly rebalanced in response to over or under usage of some channels. A message will usually make it to its destination, but we can't know for sure how it will get there. Routing messages functions very differently from broadcasting. The messages are only sent to the user they are intended for. On the Internet Simulator, we see messages appearing in the router logs multiple times, like in the image to the right. This is done to simulate a message passing through multiple routers on its way to its destination. A row is created each time it shows up at a new router. If you trace carefully, you'll notice the messages between two people don't always visit the same routers along the way. This is not a mistake. It's modeled after the way the actual internet was designed. Think, Right, Share. Why might the internet have been designed to be flexible about how images get from one person to another? Why go through all the trouble of creating multiple paths between users? Couple answers. So one is efficiency. Communication lines can become backed up with traffic. The ability to choose whichever one currently has the least traffic improves the speed of transmission. Reliability is another. Having many redundant paths means if one goes down, there are many others that a message can take. So I want you to consider the following. Think about this analogy here. So you have your mailbox, and you can put a piece of mail in that, right? Then a mail carrier will come, pick it up, take it to the local post office, then take it to the regional collection center, then the regional collection center of its destination, and then the local post office of its destination. The mail carrier is taking it to its destination, and that is to your friend's house that you mailed the letter to. So think, Right, Share, in this analogy, which parts would be the home computer, the routers, and server? When we send messages through a network, we don't actually want everyone on the network to receive them. If we include information about who the message is intended for, then we can allow portions of the network to focus on sorting and routing messages so that they can continue on their way to their intended target. In a network of computers, certain computers called routers do the same thing, directing messages toward the target computer based on the IP address included in this message. So this is just a summary slide, okay? This is the router types that we're talking about, not the power tool, okay? And think about what I just said in terms of across the network, okay? So this large network of routers. So wrapping up the lesson here, this video I highly recommend. It's an hour and 40 minutes, but the moneymaker part of this lesson starts at the 20-minute mark with the introduction of the modem. And by the 1 hour mark, he is talking about Chinese manipulation of the internet. So that part's optional, but very fascinating. You could get to this video by searching YouTube Lecture 3, The Internet, CSCIE 1 2010. And just some quick video notes that I found particularly fascinating while watching. He talks about coaxial cables. DSL is a telephone cable. Those are the big green boxes in your neighborhood. DHCP will give you an IP address of your own. He talked about a NAT router, access point, just some good things about our topic today. So just to wrap up some vocabulary, when we talk about network redundancy, we're talking about having multiple backups to ensure the reliability during cases of high usage or failure of data transmission over the internet. And a router, simply a type of computer that forwards data across a network. DOL, what are the benefits and security concerns of using a routed system of sending packets?